Good morning, students. Previous video we have discussed the variable separable methods examples, and in this video we will be discussing the homogeneous differential equation examples from the textbook. So first of all, what is a homogeneous function? If f of xy is expressed as, given a function f of xy, and if f of kx comma ky is equals to k power alpha into again f of xy, after substituting kx in the place of x and ky in the place of y, then the same function we are obtaining with k power alpha, then this alpha is said to be the degree. So if we express f of kx ky is equals to k power alpha into f of xy, then this given function is said to be a homogeneous function of degree alpha. And what is a homogeneous differential equation? If dy by dx equals to f of xy by g of xy, where f of xy and g of xy both are the homogeneous functions. Again, we have discussed the homogeneous functions before. On substituting f of kx comma ky is equals to k power alpha into f of xy. This is on substituting g of kx ky equals to k power beta into g of xy. So both should be homogeneous functions independently. So if a differential equation dy by dx equals to f of xy by g of xy, both are homogeneous functions of the same degree. So let us suppose this to be f of xy. So both should be of the same degree. So for example, its degree is k power 2, then it should be the degree 2. So k power 2, for example, k power 2 gets cancelled. We are left with k power 0. That means k power 0 into f of xy. So then that kind of a differential equation is said to be a homogeneous differential equation. I'm telling you again. So homogeneous differential equation is of the form dy by dx equals to f of xy by g of xy, where both are having the same degree. In other words, k power 0 into f of xy. Then such kind of a differential equation is said to be a homogeneous differential equation. So let us discuss all these problems. So show that f of xy equals to 1 plus e power xy is a homogeneous function of x and y. So first answer. So given function is f of xy equals to 1 plus e power x by y. So to prove that this is a homogeneous function, what do we need to prove? That's what we have discussed just before. So let us take f of kx ky. So what does it mean? In the place of x I am substituting kx, in the place of y substituting ky. So then y 1 plus e power kx by ky. Then this k gets cancelled. I am left with e power x by y. So can I write it as k power 0 into 1 plus e power x by y. This can be written as 1 plus e power x by y, k power something, k power 0 is 1. So 1 into this is this again. So therefore since we are succeeded in expressing f of kx comma ky to be k power 0 into again the same f of xy, therefore this is a homogeneous function of degree how much? 0. So he is not asking us to mention the degree, so he is just asking us to show that this is a homogeneous function. Yes, as we are succeeded in expressing f of kx ky is equals to k power something into again f of xy, therefore yes, this is a homogeneous function. And further, if we want to mention the degree is having 0. Now let us move on to the next second question. Second one, show that f of xy equals to x root of x square plus y square minus y square is a homogeneous function of x and y. So again, we will be considering this f of xy. Again, f of kx ky equals to k power something into f of xy, the same function we are getting again, then yes, it is a homogeneous differential equation. So let us do this. Let f of or given that f of xy is equals to x root of x square plus y square minus y square. Now let us take f of kx ky. So what do we do now? In the place of x, I am just substituting kx and ky in the place of y. In this, wherever you find the x, substitute kx. Wherever you find y, substitute ky. Then ultimately, what do we get in? Ultimately, so k power something into f of the same function that we have taken before has to come at the end. So let us do this. In the place of x, kx into kx whole square plus ky whole square minus ky whole square. Simply, in the place of x, I have substituted kx. In the place of y, substituted ky. So now this is kx into square root of, this is k square x square, k square y square. Take k square in common. Then x square plus y square we get minus, this is ky whole square. Now this is kx square root gets eliminated, so we left with k into root of x square plus y square minus ky whole square. So k into k is k square into x into root of x square plus y square. This is k square y square. Take k square in common in both of them, then we'll get x root of x square plus y square minus, as we have taken k square here common, therefore we are left with y square. Now if you see, this is k power 2 into the same x root x square plus y square minus y square. The function again we got at the end. Therefore, this is f of xy. Therefore, f of kx ky is equals to k power 2 into f of xy. So, k power alpha into f of xy. Therefore, this is a homogeneous function of degree how much? 2. Since it is not mentioned to express the degree here. Therefore, first of all, yes, it is a homogeneous function. So, to be more specific, of degree how much? Of degree 2. So, this is the second question. Let us try to see the third question now. The third question is, show that f of xy is a homogeneous function of x and y. So again, given that f of xy is equals to x minus y log y plus y log x. So simply f of kx ky equals to, simply substitute kx in the place of x and ky in the place of y. So this is kx minus ky log ky plus ky log kx. This is equals to kx minus ky if you take common. Ky if you take common, then we will get, if you take ky in common, then log ky minus, as we have taken minus in common, this plus becomes minus here, log kx. Now this is equals to kx minus ky into log ky is nothing but, what is log ky? Log ab is log a plus log b. So this is log k plus log y minus of, this is log k plus log x. This is equals to kx minus ky. This is log k plus log y minus log k minus into plus minus log x. So this is log k gets cancelled. So this is kx minus ky into log y minus log x, log a minus log b, log a by b. So this is log y minus log x. Now from this, let us take log k as a common. So we will get x minus k if you take common, so y log y. So minus into minus plus, since k is taken common, we are left with y log x. Y log x. So if you see here, this is of the form k into same function x minus y log y plus y log x. Same function we get there. Therefore, this is f of xy. Therefore, f of kx comma ky is equals to k power 1 into f of xy. This is a homogeneous function, to be more specific, of degree 1. So the fourth question is, express 1 plus e power x by y dx plus e power x by y into 1 minus x by y dy equals to 0 in the form of dx by dy equals to f of x by y. So for this, 1 plus e power x by y dx is equals to, if you transpose this term onto another side, minus of this we will be getting. So minus, if you multiply inside, then we will be getting this e power x by y into x by y minus 1 dy. So this is equals to dx by dy is equals to e power x by y into x by y minus 1 by, this is 1 plus e power x by y. So he just asked us to express the given function into dx by dy equals to, see, e power x by y. This is the function of x by y. x by y minus 1 function of x by y. So this is whole is the function of x by y. That is what he asked us to prove. So, and to be more specific, if you substitute k x and ky, kx in the place of x and ky in the place of y, then we will be getting that same degree both on numerator as well as denominator. To be more specific, k power 0 into same the whole f of y we will be getting. So therefore this is a homogeneous differential equation. Now the fifth question. Express this in the form of dy by dx is equals to function of y by x now. So given that this is x root of x square plus y square minus y square of dx is equals to plus xy dy equals to 0. So I'm just keeping xy dy on the LHS itself and I will transpose this term onto another side. Then integral, then this is xy dy is equals to, if you transpose this onto another side, minus of this dx will be getting. So minus if you multiply inside, then we will be getting this y square minus x root of x square plus y square dx. Now this is equals to dy by dx is equals to y square minus x root of x square plus y square by, it is multiplying, it would be dividing here, xy. Now, so this is a minus b by c, a by c minus b by c. So this is y square by xy. So y gets cancelled, we are left with y by x minus x root x square plus y square by xy. X gets cancelled, we are left with the root of x square plus y square by y. So this can be written as y by x minus this y, if you bring it in the root, it will be y square. So this is of x square plus y square by, take this y into the root, then it will be y square. So this is equal to y by x minus x square by y square. X square by y square can be written as, x square by y square can be written as 1 by y square by x square or 1 by y by x whole square plus this is y square by y square is 1. So if you see here, again I am telling you, this x square by y square can be written as 1 by y square by x square. So this is 1 by y square by x square is y by x whole square. That's what I have written here. So then if you see this, dy by dx equals to, this is y by x and this is also y by x. Therefore this is simply the function of y by x. That's what he asked us to prove. Now the sixth question is, now let us see the sixth question. Dy by dx is equals to this, and he asked us to prove or to show dx by dy equals to f of x by y. So let us see this. Dy by dx equals to this. So this cannot be proceed any further because we cannot do anything with the a by b plus c. But had it been b plus c by a, then we can further write it as b by a plus c by a. That is why, so instead of dy by dx, may I reciprocate this dy by dx as dx by dy. So that's what I am doing here. dx by dy equals to x plus y into e power minus 2x by y by y. Now this is a plus b by c, a by c plus b by c. So this is x by y plus y by y gets cancelled. So e power minus 2x by y. So this is x by y and this is also x by y. Therefore this is simply f of x by y, function of x by y. That's it. Dx by dy equals to, that's what we are required to show. Solve x square plus y square dx is equals to 2xy dy. So this is equals to dy by dx is equals to x square plus y square by 2xy. Because if we try to express it in the form of dx by dy, then 2xy by x square plus y square, from which we cannot go any further. That is why instead of dx by dy, I have opted dy by dx, so that now it has become a plus b by c, a by c plus b by c. We can do it. So now, since this is dy by dx, first of all, let us try to check whether this is a homogeneous differential equation or not. So first of all, this is the form dy by dx equals to function of xy by function of xy. So, and both having the degree 2. Both having the degree 2. Here x power 2 and here x power 1 y power 1. So both having the same degree. To be more specific, if we consider this to be f of xy, then k power 0 into f of xy we can write. How? K power 2 by k power 2, same degree. So k square by k square gets cancelled. That case can be written as x power k power 0 into f of xy. So I'll do that. So let f of xy. First of all, let us say that this is a homogeneous differential equation. How? This whole to be f of xy or capital F of xy is equals to x square plus y square by 2xy. So now f of kx ky is equals to kx whole square plus ky whole square by, this is 2 into kx into ky. So simply wherever I find x, I substituted kx and ky in the place of y. So this is kx whole square is k square x square, k square y square. Take k square in common, then we'll get x square plus y square y. So this is 2k square xy. So k square into 2xy. So yes, both the numerator and the denominator has got the same degree. K power 0 and k power 0 same. So this can further be written as k power 0 into same x square plus y square by 2xy. So the taken function again we have got ultimately. So this is f of xy. Therefore, f of kx ky is equals to k power 0 into f of xy. Therefore, this is a given function is a homogeneous differential equation. Now, so since this is f of xy is equals to this, okay, since this is dy by dx, we should express the given function into f of y by x. Since this is dy by dx, y by x, f of y by x we need to express. Had it been dx by dy, it would have been f of x by y. So now dy by dx is equals to x square plus y square by 2xy. So I'll take x square common here, then otherwise you simply divide 2xy for both of them. So x square by 2xy plus y square by 2xy. So then this x and this x gets cancelled, and this y and this y gets cancelled. So we left with 1 by 2. Since this is x by y, we can write it as x by y can be written as 1 by y by x. Because this is the dy by dx, I have to express this into f of y by x. Since this is x by y, 1 by 2 I have separated. X by y, I have written it to be 1 by y by x plus 1 by 2 into, this is y by x. This is how much? Y by x. So 1 by 2 into, this is y by x. Now, this is equals to 1 by 2 into, 1 by 2 into, this is 1 by y by x, y by x. So this is simply function of y by x only. So 1 by y by x plus y by x. So this is f of y by x. Since this is dy by dx is equals to f of y by x. Now, what do we have to do? Since this is y by x, let us take y by x is equals to y, v. From this, y is equals to vx. Now, differentiating with respect to x, independent variable, on both sides. This is equals to d by dx of y is dy by dx. Here, product of two functions, uv dash plus vu dash. V into d by dx of x is 1. So v into 1v plus x into d by dx of v is dv by dx. Now, substituting dy by dx in, so we have got this. So let us take this to be 1. So dy by dx in 1. So what is dy by dx? X dv by dx plus v is equals to 1 by 2 into, this is 1 by y by x is v plus y by x is v. So this is equals to x dv by dx is equals to 1 by 2 into, this is 1 plus v square by v. This plus v, if you transpose on to another side, it is minus v. So this is equals to 1 plus v square by 2v is LCM. So 1 plus v square minus, this is 1. So 2v into v, 2v square. This is equals to 1 minus 2v square plus v square is minus v square by 2v is x dv by dx. Now, we can clearly see this, this is in terms of v and x only. Therefore, it is easy for us to separate the variables. Separating the variables and integrating on both sides. Then we'll get how much? 2v 2v dv by 1 minus v square. So this is x by dx. If you transpose onto this side, dx by x integrating on both sides. So this is equals to 1 minus v square's derivative is minus 2v, but here only 2v is there. So for this, minus of minus 2v dv by 1 minus v square. Minus of minus is plus only is equals to integral 1 by x dx. Now this is minus. This is f dash v by f of v. Remember the result, log f of v. So this is log 1 minus v square is equals to integral 1 by x dx is log x or log mod x. So constant of integration is to be added one of the either sides. And since c is a constant, log c is also a constant. Since the whole function, whole equation is in terms of log, therefore I thought it convenient to write it as log c. So this is equals to, so bring this term onto the other side, then we'll get the log x plus log c plus log 1 minus v square is equals to 0. This is equals to log a plus log b plus log c is log a b c. So this is log c x 1 minus v square is equals to, this is 0. 0 can be written as log 1. So if you remove log on both the sides, this is log 1. Then this is cx 1 minus, what is v? Y by x. Remember, that's what we have taken before. So v is y by x. V square is y square by x square is equals to 1. This is equals to cx x square minus y square by x square is equals to 1. So this x gets cancelled. Therefore, we are left with c into x square minus y square is equals to x is the required solution. Solve x y square dy equal minus x cube plus y cube dx equals to 0. So this is x y square dy is equals to, if you transpose this onto another side, this is plus x cube plus y cube dx. Now this is dy by dx is equals to x cube plus y cube by x y square. If you see here, both numerator and denominator is functions of x and y, point number 1, and both are having the same degree, 3. Here x power 1, y square, 1 plus 2, 3, here 3. So both are having the same degree. And if you take this f of xy and after substituting f of kx, ky, we will be getting k power 0 into same function we will be getting. Why? Because this is k power 3. This is k power 3. Same degree. Gets cancelled. K power 3 by k power 3. So which is 1. 1 can be written as k power 0. Therefore, degree 0. So homogeneous differential equation, that the equation is said to be a homogeneous differential equation provided it has the degree 0. So we are getting that. So I'm just avoiding that step here. Now, since this is dy by dx, we have to express this in f of y by x. So let us do that. X cube plus y cube by x y square. So x cube, this x y square, divide with both of them. Otherwise, you can even take x cube as a common in both of them. Then we'll get 1 plus y cube by x cube by, this is x y square. So this x and this x square times it will cancel. So this is equals to 1 plus y cube by x cube by, This is x square by y square. X square by y square can be written as 1 by y square by x square. This is x square by y square is y square by x, 1 by y square by x square. So this is equals to 1 plus y by x whole cube by y by x whole square. So this is clearly a function of f of y by x, as we said before, dy by dx. So now how do we proceed? Taking y by x equals to v, let y by x equals to v, then y equals to vx. Now differentiating with respect to x, we get dy by dx equals to x dv by dx plus v. Now substitute. Dy by dx is how much? X dv by dx plus v is equals to 1 plus v cube by v square. This is equals to x dv by dx is equals to 1 plus v cube by v square. This plus v, if you transpose onto another side, it is minus v. 1 plus v cube minus v cube by v square is our x dv by dx. So this and this gets cancelled. Separating the variables and integrating on both sides. On both sides, we get v square dv equals to 1 by x dx integral. So v square dv, x by dx, if you transpose onto another side, dx by x, integrating on both sides. This is integral v square dv is v cube by 3 is equals to integral 1 by x dx is log x plus constant of integration log c I'll take. What is v that we have taken before? Y by x. So this is y cube by 3x cube. V is y by x whole cube, y cube by x cube into 3, y cube by 3x cube. So log a plus log b, log a b log cx. Therefore, y cube is equals to 3x cube log cx is the required general solution. Solve dy by dx equals to x square plus y square by 2x square. Again, this is dy by dx is function of xy in the numerator by function of xy in the denominator. Both are having the same degree 2. So, then after simplification, k power 0 into the same taken function we will be getting. If we take f of kx, k by equals to. So, therefore, this is clearly homogeneous differential equation of degree 0. Now, dy by dx equals to x square by 2x square plus y square by 2x square. So, x square gets cancelled. So, this is 1 by 2 plus 1 by 2. This is y square by x square is y by x whole square. So this is clearly function of y by x. So take 1 by 2 as common, then 1 plus this is v square is dy by dx. 1 plus y by x whole square. So this is clearly function of y by x. So let us take y by x as v. Let y by x equals to v, y equals to vx. Differentiating we get dy by dx equals to x dv by dx plus v. Substitute here. X dv by dx plus v equals to 1 by 2 into 1 plus v square. X dv by dx is equals to 1 by 2 into 1 plus v square. This plus v, if you transpose onto another side, minus v. So 1 by 2 into, this is 2 LCM, 1 plus v square minus 2v. This is equals to v square minus 2v plus 1 by 2 is our x dv by dx. This is equals to 2 dv by v square minus 2v plus 1 is equals to x by dx is dx by x. Separating the variables and integrating on both sides. This is 2 dv by v square minus 2v plus 1 x by dx. If you transpose on to another side, dx by x. So integrating. So 2 into 1 by v square minus 2v minus 2v plus 1 is simply this is v minus 1 whole square dv is equals to 1 by x dx. Now this is 2 into integral 1 by x square dx is minus 1 by x. So this is minus 2 by v minus 1 is equals to integral 1 by x dx is log x plus constant of integration c. So this is minus 2 by v value is y by x. So this is y by x minus 1 is equals to log x plus c. So minus 2 by y minus x by x is equals to log x plus c. So this is minus 2x by y minus x equals to log x plus c. So take minus common and cancel, we'll get 2x by x minus y is equals to log x plus c. Therefore, 2x is equals to x minus y times log x plus c is the required solution.